My name is Atharva Jain, and today I want to talk about responsible AI, not as a buzzword or policy idea, but as something we actually build into systems. I'll use a real research example to show how safer, more trusted AI looks in practice. So, talking about myself, I work as a researcher at the National Center for Supercomputing Applications, where I've worked on AI systems used in high stakes biomedical research. That experience has shaped how I think about AI, especially the importance of keeping humans in control and designing systems people can actually trust. Before I get into my research example, I want to set the motivation for responsible AI. AI is now being used in high stakes domains, especially healthcare, where errors can directly impact real people. A key problem is that lab success doesn't always translate to real world reliability. In the real world, data is messier, conditions can change, and assumptions can break. And the most dangerous failures are the silent ones, where a model gives an output that looks reasonable but is wrong and nobody notices it in time. That's why responsible AI matters. It's about designing systems that are safer, more reliable, and trustworthy when the stakes are high. So, responsible AI isn't just a policy idea, it's shaped by engineering choices, which I'll summarize next. When we talk about responsible AI, it's important to recognize that it's shaped by engineering choices made early in system design. It's about transparency, whether humans can understand outputs, robustness, whether systems behave reliably with messy real world data, accountability, making sure that the responsibility stays with the people, and human alignment, which ensures that AI supports judgment instead of replacing it. Now, let us talk about my research with NCSA and how it ties into the whole responsible AI agenda. Metastatic tumors are cancers that spread from their original location to other parts of the body, making them significantly harder to treat. Most cancer related deaths occur due to metastasis rather than primary tumor. So, according to this, our research was aimed to understand how genes behave within the spatial structure of tumor tissue, especially considering how they would respond to therapies and external stimuli. So the end goal of the project was to generate insights that help biologists design more personalized and effective treatment strategies with AI supporting, not replacing scientific decision making. So the image here shows spatial gene expression inside a breast cancer tissue sample that we collected using xenografted tissue samples from real-world patients with the help of University of Chicago, Illinois. Instead of averaging gene values, spatial transcriptomics preserves where the genes are active. So as you can see here from the visualization that the gene that we're specifically looking at is FASN in this case, and you can see where the confidence intervals are overlapping in terms of a hotspot or where they're overlapping in terms of a cold spot. So these patterns essentially reveal biologically meaningful structure that would be lost in a traditional ML pipeline. And responsible AI in this context means that we want to make the models interpretable and grounded in real tissue context. Now let's look at a set of more comprehensive gene analysis visualization, this time from a lung cancer patient. My role in this research primarily focused on hotspot analysis, which was identifying regions where the genes are consistently co-localized. We present results at multiple confidence levels to avoid overconfidence. These outputs are sent to biologists who decide which genes are significant and worth experimental validation. The key idea here is that the AI supports scientific judgment, it doesn't replace it. Talking about why this approach mattered to us so much, and simply because it changed how AI was used in the research workflow. Instead of blindly trusting model outputs, biologists could reason about spatial patterns, uncertainty, and significance before running experiments. That separation, where AI informs but humans decide, is what makes systems safer and more trustworthy, especially in high stakes domain like healthcare. So, talking about building trusted AI systems, there are certain points I would like to bring up. Firstly, being designed for uncertainty. Real world data is noisy, incomplete, and constantly changing. Designing for uncertainty means accepting that models will sometimes be unsure and making that uncertainty visible rather than hiding it. Systems that acknowledge what they don't know are safer than systems that pretend to be certain. Preferring interpretability. Interpretability isn't just about explanations, it's about whether humans can reason about a system's behavior, especially in high stakes settings. Simpler one or more transparent models are often more trustworthy than complex black boxes, even if raw accuracy is slightly lower. Benchmarks tell us how a model performs in control settings, but real world conditions are rarely controlled. Testing beyond benchmarks means evaluating under distribution shifts, edge cases, and unexpected inputs where failures are more costly. In responsible systems, AI supports human decision making rather than replacing it. Humans remain accountable, and AI acts as a tool that surfaces insights, highlights uncertainty, and enables better judgment, especially when the stakes are high. When we design AI systems this way, trust becomes a feature and not an assumption. The future of AI won't be defined by how powerful our models are, but by how much trust we put in them. Responsible AI doesn't slow progress, it makes progress sustainable. Thank you.